Okay, in this video we will try to demonstrate our damped harmonic oscillator using Arduino. So damped harmonic oscillator and oscillator where this is we can assume this is a device. We have a spring and a mass system. So if you make an oscillations, this will normally come to a stationary equilibrium position after some time. Not in the case of a undamped harmonic oscillator, which will retain its displacement for long time. Okay, in normal case we always have damping, so that this will come to bring back to its initial position. So in this experiment we will try to implement this one using a scale. So what you do is we put a steel scale on a support, and we will place your Arduino in the down. So this will become an obstacle. So this will measure the distance from here and here, and the variations in distance. So if you are displacing here, the same displacements we can actually measure using the Arduino. So that actually become a measure for this damping. So we may get the curve graph like oscillations like this, and it will damp like to 0 your equilibrium position. In order to measure the damped harmonic oscillations, we need to place one scale, a steel scale like this, okay, on the rigid support, and we should place like this. So if we can hold here and oscillate, this will make oscillations. To measure the oscillations, you have to place your sensor that we discussed in the last video like this, so that this scale will make an obstacle for the this sensors. Okay, after making the connections, we can directly connect to the here to this cable to the computer. Okay, so in order to see our variations in damped harmonic oscillations, we have to go to Arduino. This is the connections we made: echo pin 2 and trigger pin 3. So we can see here, and we can do the same thing. So this is a long durations, float distance, etc. we had to do, and we also want to connect the ground and VCC pin into the Arduino. Okay, so after making the connections, we can go to tools and check that this Arduino board was connected. So this is now connected to COM. If it is not connected, you should select CM3 or your what it's showing, it's maybe CO3 or CO2. You have to select, then you have to run the code. Okay, it's showing the code is successfully running. Okay, then what you do is you have to see your data. So you can go to serial monitor. So it's showing about 9.2 fixed value because the obstacle is not moving. Okay, so if I try to oscillate my scale, so it's showing some variations. So in order to see it clearly, you can go to serial plotter. So we can go to serial plotter. So initially you're doing some values like this because you cannot, there should be maybe some hump like this, so it not be clear. Okay, so if that is going, you can show it's about showing a 9 something. So if I oscillate my scale, you can actually see the damped harmonic oscillator motion. Okay, each time I am plugging my scale, this is showing a variations in the serial plotter. Okay, so in order to see this data clearly, I have added one plugin. So this is the plugin I had. This is called Arduino spreadsheet. This was installed using separately, so that I can get the data in Excel sheet. So I can press here. So a separate sheet will come. So this will record the data. So I take a few more plugs on here. And after making the pluggings, I save the data. So I can save the data wherever I need it. Okay, so just saving in desktop. I will give a damped harmonic motion, then it is saved in the desktop. Okay, so I can close this one, so I can stop the data, and I can go to damped harmonic motion data. Okay, this is the data we got in the Excel sheet. So we can select the data from here to here. So if you are showing any character, you can delete the character up to that row, and we can go to insert options, where we have the option to line plot. So this is a line. We get a series of oscillations here. So in order to see a particular say maybe here, so I can select that X scale. So you have to double click on this axis, then you have to give this option on the scale range. Okay, so this is a minimum, so you have to give about the minimum is about I can give is about 4.2. then the maximum I can give up to this is maybe about 7. Okay, then I can give, so I can see the oscillations here. So this is oscillations, this is equilibrium point, and we also need to give this axis titles. So axis titles are chosen, so we have to give here as this is a displacement in centimeter, then we also need this so we need to put the X label as a time, so you can give this as time in second, then you also need to give the title. So the title I will give is this is my damped harmonic oscillator, Okay, so if I made all this labeling, I can copy this data and any of this Word document, where we can place this Word document and we can use it for any future purposes. Okay, that's why we tried to implement our damped harmonic oscillator Arduino.